AMD has been really busy preparing for the future. Its survival is on the line. Even though AMD doesn't have an actual Tiger yet, it does have some Bobcats and Jaguars in its infantry. Rather than fighting Intel directly in the high-performance desktop and server markets, AMD is moving its heterogeneous expertise beyond high-power, expensive computers. Bobcat and Jaguar are just two examples of AMD competing in low-power computing. For some background on the Jaguar APU coming to the PS4, check out Chip Wars 14. But this video is mostly about AMD's heavy machinery, the bulldozers, pile drivers, and steamrollers bringing AMD's multi-threaded power to desktops and servers. First, some background. AMD has been facing an existential crisis as it tries to define its uncertain future. In 2009, AMD had to sell its expensive chip fabrication factory to global foundries. So now, like ARM Holdings, it's completely focused on chip design. AMD's current high-power cores were really born in October 2011 with a brand new microarchitecture completely redesigned from the ground up. Like a real-life bulldozer, this chip cleared the way for all subsequent desktop and server processors. Bulldozer was the first major release since the famous Athlon 64 put the Pentium 4 to shame back in 2003. As we learned in Chip Wars 18, in 2006, Intel fought back with the now dominant core architecture iterating on the powerful tick-tock cycle. This aggressive cycle of innovation has forced AMD to compete on price and value. With Bulldozer, AMD introduced a chip with 4 modules that run up to 8 threads.
That sounds confusing.
Part of the confusion comes from the fact that Windows recognizes 4 physical cores and 8 logical or virtual cores that can run up to 8 threads.
I know what a core is. But what's a thread?
A thread is a task that can run at the same time as other software tasks. Most developers make software that runs on only one main thread, since it's a lot easier to debug. But some complex programs that do things like encoding and rendering will benefit from multiple threads. For a single program to be multi-threaded, however, developers have to write code in a specific and time-consuming way. You see, an innovative hardware architecture isn't enough to boost performance. Chip companies like AMD need software support from the developer community. For example, at first Windows 7 wasn't optimized for Bulldozer, so the initial reviews weren't so good. But then after a patch, and now with Windows 8, the operating system better distributes multi-threaded tasks for the Bulldozer family of chips. This is huge for people who need to run multiple programs at the same time.
Wait a minute, so are these AMD chips 8 cores or what?
Each Bulldozer module has 2 integer cores. Since each core has its own L1 data cache, some people will refer to a quad-core module chip as an 8-core architecture. That's kinda true and kinda not. They aren't fully independent cores in the way some people define a core. The problem is that each of the 4 modules share a pair of 128-bit floating point units that together match the 4 256-bit floating point units in Intel's latest chips. So in terms of floating point cores, the Bulldozer is really a quad-core.
Sounds like some marketing trickery to me.
AMD is betting on a future where floating point calculations might be increasingly coded for GPUs, not CPUs, as part of a heterogeneous system architecture. Despite the AMD FX 8150 setting the 2011 overclocking record, AMD hoped that more developers might take the time to parallelize their floating point code for the GPU, while only using the CPU for integer serial calculations. But for that to happen, there needs to be enough of a potential market for developers to spend their time to optimize their code. So when it was released, Bulldozer got clobbered in common single-threaded performance benchmarks, the most common software in use at the time. So recently, AMD gave it another go with Bulldozer's successor, Pile Driver.
I see a theme here.
Released in late 2012, first in AMD's APUs, the Pile Driver core is an incremental update to Bulldozer. In powerful desktops and servers, when stacked up against Intel's Ivy Bridge processors, the Viscera FX with Pile Driver cores continue to perform better with multi-threaded code like video editing, streaming, and number crunching, as well as multitasking. But for most single-threaded games and apps, Ivy Bridge still did better. So AMD responded by dropping the price of the second-generation FX chips to sell through their inventory. But the real game changer could be the Trinity series of low-powered accelerated processing units. Like we started talking about in Chip Wars 14, AMD's APUs are a heterogeneous system architecture that combines the power of CPUs with the efficiency of GPUs, all on a single system on a chip. Released in October 2012, Trinity outperformed Intel's Ivy Bridge HD 4000 integration integrated GPU, but the problem still remains. Most software developers continue to optimize code for single-threaded CPU performance, things that Intel chips are great at processing. The problem for developers is that CPU and GPU data structures are very different and normally don't mix very well. And while more code could be written for GPUs, developers don't really have a lot of time and would rather write code that they're already familiar with. So AMD has been cooking up something that will make writing code for heterogeneous architectures a lot easier for developers. First, the problem. Logically speaking, the CPU and GPU memory pools are separate. In AMD's heterogeneous system architecture, even though the CPU and GPU share the same physical memory, according to the software, each architecture has its own unique pointers referring to separate sets of data. For example, if the GPU needs some data stored in the CPU pool of memory, a program has to copy the data from the CPU memory to the GPU memory in order to do the GPU calculations, and then move it back afterwards, even though the data is physically on the same chip.
What a waste.
Coding for this takes a lot of time, and it actually makes life a lot harder for developers. This is where AMD's new heterogeneous uniform memory access swoops in to hopefully save the day. Any update to memory, whether it's from the CPU or GPU, will be synchronized for the entire system. No more copying and moving busywork. Now the GPU will be able to directly access the CPU's entire memory space, including virtual memory, a pool of memory traditionally reserved for CPUs whenever large datasets need to be stored onto the hard drive. This could especially be useful when rendering larger, more realistic 3D graphics textures. Unfortunately, we'll all have to wait to see this technology in the market. The first AMD chip to have this support will ship at the end of 2013. Codenamed Kaveri, this APU will combine AMD's upcoming Steamroller cores with an integrated GPU that has full access, physically and logically, to a unified pool of system memory. But this might not be the only implementation. Major ARM processor vendors have joined the HSA Foundation expressing support of heterogeneous architecture innovation. So this could even be used for an x86/ARM hybrid chip. See Chip Wars 1 to learn about the difference between the two. But as we've seen before, the real-world benefits of these innovations really depend on whether developers will use these tools to write their software. And with the AMD APU in the PlayStation 4, and possibly the next Xbox, there's a good chance that AMD tools could become industry standards, starting with game developers. So the Chip Wars battle for computing supremacy is converging on processors that use multiple CPU cores, many GPU cores, and other specialized chips all on a single piece of silicon. And while Intel is using its advantage in manufacturing and single-threaded processing to cram more performance into its upcoming Haswell processors, AMD will be showing off its developer tools and chip architectures in the 8th generation consoles, and hoping to lay the groundwork for more power-efficient heterogeneous optimized software development. And here's a customary shout out to all the latest subscribers. If this is your first time listening, I usually don't sound this bad. Please check out the channel and leave a comment or thumbs up to let me know what you think of the other videos. This feedback actually raises the search rankings of each video and hopefully helps other people discover the channel. And if my bosses at work are listening, let this be proof that I am really sick. As some of you subscribers know, for my day job, I work at a cash register in a department store. While it's one thing for me to record a 6-minute video, I definitely couldn't handle customer complaints for an 8-hour shift. Sick or not, I will definitely post an update to the Gaming Wars series after tomorrow's Xbox event. So stay tuned, as I'm betting we'll see more AMD multi-threaded power coming to the last of the major console announcements this year. Thanks for watching as we all try to find out what's coming up next.